Hi, welcome. Today we are going to discuss about the rate of heat release rate in CA engine. Wait a minute. What happened? I want to go to next slide. Yeah. So the rate of heat release rate. So in this diagram, we have seen that the rise starts from B. Actually, from A to B, it may be in the negative dip, negative side. So from B onwards, it is going to be the heat release rate is going to be increased. As we have discussed the stages of CI engine in the previous videos. So the stages of combustion in CI engine, it comprises of 4 stages. One is ignition delay period, second one is pre-mixed combustion, third one is mixing and controlled combustion, and late combustion phase. Okay. So now we are going to see about the how the heat release rate will be. Okay. So this is the insightful tool for analyzing the combustion inside the compression ignition engine. Okay. So unlike the cylinder pressure curve, okay, the P theta diagram we have discussed, right? So unlike cylinder pressure curve, the rate of heat release plot directly tells us how much and how fast chemical energy is being converted from fuel at every instant during the cycle. Okay, have you understand the concept? So once again I repeat, unlike the cylinder pressure curve, the rate of heat release plot directly tells us how much and how fast chemical energy is being converted. Okay. So before combustion, there were a small negative dip. Actually, I have said to you, right? A small negative dip from A to B. Okay. So this is the heat absorbed to vaporize the fuel during the ignition delay period. That is the initial preparatory phase. Okay. Which is not shown here. Okay. That is where it is shown from B. Okay. But many research studies, we can witness those negative dip. Okay. If you have taken any journal, you might have seen this negative dip. Okay. Now let's trace the path. Okay. When combustion begins, the sharp and tall peak represent the pre-mixed combustion. The height of the spike shows the intensity, that rapid burn. Okay. A higher and narrower peak means a more fuel were prepared during the delay period. Okay. And it leads to a noisier and harsher combustion. Okay. Following this spike, the curve transitions into broad. Okay, it is going to be broad trend. Okay, this is a mixing control or diffuser combustion phase. Okay, here the burning rate and thus the heat release rate is controlled by how fast the fuel vapor mixes with air. How fast the fuel vapor mixes with air. Okay, which directly tells us the engine load and power output. Okay, the shape is there, right? Okay, the small peak. Okay, the shape. Okay, and its duration, the crank angle duration. Okay, is directly correlate with the engine load and the power output. Okay, and finally the curve tails off in late combustion phase. Okay, and then the heat release. Okay, here the release here is insufficient. As the piston is descending, okay, the primary contributes to high exhaust temperature and soot formation. Okay, so what I'm trying to say is in the final curve tails, okay, the final curve tails, okay, in the late combustion, which means the afterburning phase, any remaining heat releases here is inefficient. Okay, because as we have seen that only a very small fraction of fuel is burned in the late combustion. Okay, so the major portion of fuel is burned in the pre-mixed combustion. That is why the heat release peak is higher. and the remaining major portion of fuel is burned in the mixing controlled combustion phase or diffusion control phase. That is where the peak is less than in late combustion phase. Further, the energy efficiency, which means the rate of heat release rate, is further reduced. Okay. So thank you. In subsequent slides, I will bring you some new insights about the engines. Thank you. Thank you. We will meet in another good video.